This video is on percent concentration and dilution factors. Here's an equation we're starting with. Percent concentration is the mass or volume of a component or reagent or medicine divided by the total mass or volume, and that includes the component or medicine or reagent. And then since it's a percentage, we take what would be that fraction or decimal and multiply it by 100. Let's do this problem. What's the percent by mass or percent concentration of a solution that contains 26.5 grams of glucose with 473.5 grams of diluent? This is kind of a funky word, diluent. It means that that's the non-medicine part. So that might be water or saline solution or something else, just something to hold the medicine in. Okay, so if we want to find the percent concentration of this, what we have is we have the medicine part divided by the total times 100 to change it into a percentage. So in this case, that's 26.5 grams of glucose divided by 473.5 grams of diluent plus the original 26.5 grams of glucose. So that denominator is the total. And then we just multiply that by 100. This turns into 26.5 divided by 500 times 100, which works out nicely to 5.3. So this solution is 5.3% glucose. This is related to the idea of dilution factors. So dilution factors are the percent concentration without the percentage. So it's just that fraction of medicine or reagent part divided by the total. So we leave them as a ratio. We leave them as a fraction. So a dilution factor of 1 in 10 means that the solution is, pause the video and try and figure it out. All right, it means that the solution is 1 part sample and 9 parts diluent, not 10, because we know that this denominator is the total, which means we have 1 over 1 plus 9 more would be the same thing as 1 over 10. So what is the dilution factor if we add 0.7 milliliters of medicine to 6.3 milliliters of diluent? So I have the medicine part, 0.7 milliliters, divided by the total, which is 0.7 plus 6.3 milliliters. Notice that the units simplify out since this is just a ratio, and we're left with 0.7 over 7. To simplify that, I know I could reach for my calculator, but let's do this by hand. Decimals and fractions don't play well together, so I'm going to multiply this by a form of 1, by 10 over 10, in order to clear that fraction, or clear the decimal, sorry. So 7 times 10 is 7. 0.7 times 10 is 7, and then 7 times 10 is 70. This, I can see, simplifies down to 1 in 10. All right, so there's that. How much diluent do we add to a 0.7 milliliters of medicine to achieve a 1 in 10 dilution factor? I know this is the question we just did, remixed. I know the answer is going to be 6.3 milliliters, but let's go through the steps. So I know that the dilution factor is the medicine part divided by the total, which means the medicine part, I'm told, is 0.7 milliliters. And so there's got to be some amount of diluent that I'm adding in, plus the original medicine part again. So we've set up a proportion here. 1 over 10 equals 0.7 over x plus 0.7. We can solve the proportion by cross-multiplying. 1 times x plus 0.7 is x plus 0.7 equals 10 times 0.7, which works out to be 7. Subtract 0.7 on both sides, And we find that X, which was the amount of diluent, was 6.3. So we need 6.3 milliliters of diluent. We will do another dilution problem in another video.